Hey everybody, welcome into this first video on trig substitutions. In this video I'd like to compute an integral that we know how to do, so let's write it down and write down the answer first of all. So this is the integral of 1 over square root 1 plus x squared dx. And recall that this is what we call a stare-at-it integral. This is one that we know. So when we studied hyperbolic trigonometry, this integrand here is the derivative of arc sinh. So that means that the integral itself, or the antiderivative, is equal to the arc sinh function, or inverse sinh, of x plus c here. This can be written, as we know, as sinh inverse of x plus c, or remember there's a formula for arc sinh, and that formula is that arc sinh is equal to the log of x plus the square root of 1 plus x squared. And so any of these are legitimate answers to this antiderivative, this integral. Let's compute this another way, though. So the whole point of this is that we want to learn a method for computing integrals like this, all right, that we can't just stare at, so that we have to do something else with. So I'm going to scroll down a little bit and rewrite the integral. So here's our method, our new method. For this one, what we would like to do, so this is the title of the video, is trig substitutions. What we would like to do is make a substitution here. And so in this video, I'm just going to make the substitution, then we'll talk about it in the next video about why this is a good substitution and how we decide what to substitute. But the idea here is that we want to substitute out the x for a trig function, okay? So we want to choose a trig function for which we can get all the values of x that are in the domain of this function. And by the way, the domain of this function is all real numbers. And then for which we can actually compute the integral with respect to that new variable. So the substitution that I'm going to make for this one is I'm going to let x equal tangent of theta. And now remember that the range of tangent is all real numbers, okay? But tangent is periodic, so we have to choose a domain or a restriction on the theta values here, so that we only so that this substitution is well defined. And so the choice that I'm going to make is for the theta to be on the right hand side of the unit circle. So a single period of the tangent function. So this will be as theta varies from negative pi over 2 to pi over 2. Now, whenever you make a substitution, you can choose your variable to substitute. Usually we do this the other way around, right? We let u equal some function of x, and then we have to find du. In this case, we're letting x equal some function of another variable, theta in this case, and we have to find the dx, right? So we have to compute dx. Dx is the differential of this side, so that's the derivative, which is secant squared theta d theta. And then at this point, I mean, you're probably already wondering why. So why? Like, why are we making this choice, right? And I just did this kind of by instinct first, but really what I should have done is justified why I chose this one, right? And so the reason that I'm choosing x equal to tangent theta is because tangent squared theta plus 1, this is a Pythagorean identity, right, is equal to secant squared theta. All right, and there's another good piece of information here that we're going to use. So remember, I chose to restrict our tangent function so that we were looking only at the right hand side of the unit circle, and over here secant is always positive. So on this side of the unit circle, secant is well defined because secant is 1 over cosine, and remember, we're not including negative pi over 2 or pi over 2. Those are not included in the domain of tangent to begin with. And on this side, secant theta is always positive, right? So if secant theta is positive, so we'll write that here. Then what do we learn, right? Well, then we can take the square root. So on our restricted domain for theta here, we can take the square root of both sides, and we can say that actually secant theta, so when you take the square root, you don't have to worry about the absolute value, is equal to this, right? So I'm going to rewrite this as 1 plus tangent squared. That's just changing the order, right? But look at our tangent is equal to x, right? So actually secant theta is actually equal to 1 plus x squared. And that's this, right? And so that's the reason for making the choice of x equal to tangent, because now we get, by the Pythagorean identity for trig functions, we get that secant theta, so the bottom, the denominator of this fraction is going to actually become secant theta. All right, so let's go back and sub in, because we've got everything that we need now. So this whole term, right, is going to become this. That's just going to be secant theta. And then the dx we always need, right? So dx is going to go there. And let's see what happens. And we can use previous knowledge when it comes time to actually integrate this. But our integral becomes, so 1 over the square root of 1 plus x squared dx. This integral becomes secant squared theta d theta, integral of course, right? Over, the bottom is just secant theta, right? And again, secant's never zero, and secant, ever, right? Secant's never zero, and secant is always positive here. So we can cancel one of these, and this just then becomes the integral of secant of theta d theta. And this is one that we worked out in previous lecture videos, the integral of secant, but it turns out that the integral of secant theta d theta is equal to the log of secant theta plus tangent theta plus c, of course, right? And at this point we need to plug back in, right? So we did this integral, the integral of 1 over square root 1 plus x squared dx, but we got an answer with thetas. So the last step is to go back and plug in our x, which is part of the, or our tangent I should say, which is part of the answer, and our secant, which is part of the answer. So for this one we already have the two trig functions that show up in the answer, and we end up with natural log of secant is a square root of 1 plus x squared, really it's this one, right? Plus tangent theta is just x plus c. And if we scroll back up, we will see that that is one of the forms of our answer, right? From our stare at it, right? And so this integral down here that we've done has been computed using a trig substitution. So a very careful choice of x in terms of a trig function. Considerations about the domain and the range of that function. So remember, this choice of x covers all the values of x in the domain of the original integrand. And then considerations about like why we chose that function, right? And we ended up with the same answer, and so therefore it worked, right? It was an acceptable method. And so in the next video we'll talk about how we can extend this to general integrals that we don't already know the answer to.